In this tutorial, we're going to talk about calculus, integration, and our main focus will be on partial fractions. So let's see how we can evaluate partial fractions and integrate them. The first question or scenario I have is whereby you've been given (5x minus 1 over x squared plus 5x plus 4. So the general idea about partial fraction is that when you've been given, let's say, 3a plus b over a maybe plus b, they want you to make it in a form maybe 3a maybe over a, maybe let me put 2 there, plus b over 2b. They want you to separate the two fractions, or to separate the original fraction into parts, into halves. Okay, that is the general idea. So this is what we want to talk about. So how can you express this into partial fractions? So you can start by factorizing this. When you have x squared plus 5x plus 4, the product is equal to 4, the sum is equal to 5, the factors are just 1 and 4. So what we have is x squared, then plus x plus 4x plus 4. Then you get to factorize this to definitely give you x. We open the bracket, x plus 1, then plus 4, then x plus 1. So by combining this, we have x plus 4, x plus 1. So this is what we are going to put there. So it will be 5x minus 1 over x plus 4 in parentheses x plus 1, like that. So we're going to say, let this entire fraction be equal to, in parts, we have to get a certain value there on the numerator over x plus 4. Then we separate this plus b over maybe x plus 1. So this will be in parts. You will separate just the denominators. What are we going to have? So at this point, you can just equate. Okay? You can do something to this fraction by making it similar to this. So what we can do, since we can just find the common denominator, which is actually x plus 4, x plus 1. Then we get to say, what is x plus 4 into x plus 4, x plus 1? The answer will be x plus 1. So x plus 1 multiplied by a, so x plus 1, like that. Then x plus 1 into x plus 4 plus x plus 4, x plus 1, that is multiplied by b, so it will be b open bracket x plus 4, like that. So this will be equal to 5x minus 1 over x plus 4, x plus 1. So we can now evaluate this. So this can be equal to a times x, that is ax, a times 1, that is a, plus b times x, that is bx, b times 4, that is 4b. Okay, then over x plus 1, x plus 4. Multiplication is commutative, so even if we write it like that is okay. So x minus 5x minus 1 over x plus 4, x plus 1. Then you see that when you equate, the denominators are the same, so it can cancel. This denominator can cancel with that denominator, it's just the same. If you multiply on the numerator by this denominator, even on this side by this denominator, you'll definitely get a 1. So they will cancel to simplify things. Then you just deal with the numerators. So what would be the numerators? So the numerator can correct the like terms, so it will be ax plus bx, then plus a plus 4b is equal to, I equate to 5x minus 1. You see, when I have this, I can just compare. I can say I factorize a here, so I factorize x rather, so it will be a plus b, then x, then plus a plus 4b is equal to 5x minus 1. So I can compare that a plus b is equal to 5. Okay, so a plus b is equal to 5 because that is what have x. So a plus b is equal to 5 because it has the coefficient which is x there. Then I'll say a plus b is equal to, that is a plus 4b is equal to negative 1. So what I can say is I can make a the subject. So I'll say a is equal to 5 minus b. I can substitute on a on this side. I can substitute now. I'll do the substitution. So it will be where there is a, I'll substitute 5 minus b. So 5 minus b there where there is a, then plus 4b is equal to negative 1. So this will be equal to 5 minus negative b plus 4b, that is just a 3b, right? So 3b is equal to negative 1. This, I can take this 3b to the other side, so it will be 3b is equal to this one to the other side, it will be 5 plus 1. So 3b is equal to 5 plus 1, that is a 6. We divide by 3 on both sides, so my b will be equal to 6 divided by 3, that will be a 2. Then I can now come here to find the value of a. So what will be my a? So my a will now be equal to 5 minus b, which is a 2. My a will be 3. So I have the values a is equal to 3, b is equal to 2, right? Then I can substitute in that partial fraction which I separated. Okay, so what I separated was, where is it even? Okay, so I had this, so since I have a and b, when I factorized that denominator, it was x squared plus 5x plus 4. So I got x plus 4. Okay, the factors were x plus 1 as the denominator, x plus 4. So I had a over x plus 1 plus b over x plus 4. So I can now replace, so this will be now equal to, where there's a, I'll put 3, so it will be 3 over x plus 1, then plus b is now 2, so it will be plus 2 over x plus 4. At this point I can now find my integral. So since we're dealing with integration, integral of 3 over x plus 1 dx plus integral of 2 over x plus 4 dx. Okay, so integration of this is the same as I have what is the integral of 1 over x. Integral of 1 over x with respect to x is equal to ln x. Okay, so this is the one I'm going to apply here. So integral of this, I can just remove 3 there, then I'll say integral of 1 over x plus 1 dx plus I remove 2, integral of this will be 1 over x plus 4 dx. So I can now integrate this. What I'm going to have will now be equal to 3 integral of 1 over x plus 1, that is ln x plus 1, then plus integral of this 1 over x plus 4, so it will be 2 ln x plus 4. Then I'll put plus c because this is not a definite integral. So this is the answer. Now let's look at the second question. The second question which we have is 5x plus 7 over x plus 2 square. Then we've been told to integrate this by partial fraction, right? This is partial fraction. So what we need to do is the same procedure. So it will be a over, for this one we're going to say the first one won't have any power, so we're going to say x plus 2. Then the second one, b, will have the power x plus 2 square. This is how you get to separate this in partial fraction. Then what I'll do now, I can find the common denominator. The common denominator this side is just x plus 2 square, right? So I'll say x plus 2 into x plus 2 square. It is just x plus 2. Then plus this will be 1 times b, so just be b. You see, right? So we're going to replace it there. So what I'll have is a multiplied by x, it will be ax plus 2 multiplied by a, it will be 2a, then plus b over x plus 2, like that, square. So I can now equate. You see that x square and x square, they are x plus 2 square and x plus 2 square, they are denominator, so they can cancel out. So what I can have is 5x plus 7 is equal to ax, then plus 2a plus b. At this point now I can equate. So my a, which has x, is just 5, so a will be 5. Then what will be my b? So b will be 7 plus 2a plus 7, 7 is equal to 2a plus b. Where there's a, I'll substitute 5, so 7 is equal to 2. Where there's a, 5 plus b. What will be my b? Let me just get rid of this. So my b, we have 7 is equal to, okay, 7 is equal to 2 times 5, that is a 10, plus b. So what will be my b? My b will be equal to negative 3, right? Okay, so I have a and I have b, so I can now write it in partial fractions. So my A is 5. Okay, let me write it here. My A is 5, my B is -3. So I can now use partial fractions. Can write this as my A is 5, so 5 over the first denominator was x plus 2, then plus, so because of this -3 I'll say minus, because positive multiplied by negative is just a negative, so -3 over, then the second denominator the square. So this is the partial fraction. Then to integrate this, I'll say integral of 5 over x plus 2 with respect to x, then plus integral of -3 over x plus 2, like that, square. Okay, now let's integrate. Let us integrate this. How can we integrate? So to integrate this, I'll remove first 5 on this one. I'll remain with 1 over x plus 2 dx. We are integrating, right? So dx, then plus, for this one also I'll say integral of -3 over x plus 2. Okay, this is a special case, dx. Okay, so to integrate this, for this one I'll just say this is equal to 5 integral of 1 over x plus 2. We said it's linear, then you write x plus 2, then it will be plus. Now let's deal with integral of -3 over x plus 2 square dx. So how can we integrate this? So I can write this. Let me deal with this. So let's first hold on this. We deal with this one. So what I'll say is same as integral of -3 open bracket x plus 2 to the power -2, then dx. So I can use integration by substitution, whereby I'll say let u be equal to x plus 2, what is in the brackets. Okay, so I'll now say I'm integrating. So I'll say u is equal to x plus 2. So I'll differentiate this. I'll say du over dx will be equal to, d over dx is equal to 1, meaning that when I multiply 1 times dx, I'll just have dx is equal to du. Okay, so I can now substitute in this equation. Since dx is equal to du, I'll substitute. Remember, our u is equal to x plus 2. Let me write it here. U is equal to x plus 2. Let's now substitute. So I'll say integral of -3 open bracket u to the power -2. Then where there is dx, we said dx is equal to du. Okay, then let's integrate this function. So this will be equal to what? -3 integral of this, same as saying -2 plus 1 over -2 plus 1, then we say plus c. So this will be equal to -3, then u to the power, this is -2 plus 1, -1 over -1, then plus c. Okay, we now finish this. So negative multiplied by negative, negative divided by negative is just a positive. So what we have is 3u to the power -1, then plus c. We can write this as 3 over u as a denominator, then plus c. Okay, it's now simple. We can now bring back u. We had to let it to be x plus 2, so we can now bring it back, so it is 3 over x plus 2, then plus c. We've integrated this, so I can just add now to this one which I integrated. Okay, so it is 3 over x plus 2. So this is the one I'm going to add here, the integrated one. So it is plus 3 over x plus 2, then plus c. So this is how to integrate this partial fraction. Okay, this is basically how you can integrate it. Thank you for watching.